So it's 1 week later, and let's get to it. So let's first tear down the Flextronics one. We expect this to look very nice on the inside. And yeah, let's start off by trying to remove this earth pin. At least I think it is connected to earth. Yeah, no, it's not moving. It is definitely way better connected than this dud one, right? I actually do expect it to be connected to some kind of internal earth. So this, let me try it once more, but nah, this ain't moving. Alright, so up next, try to get into the case and try to find a smart way to do it. So indeed, this this metal stud is connected to the board through this wire here. So this was connected to the earthing wires actually on the cable that you can plug in. So that one actually does have the earth pin connected to this on the larger chargers. So a lot of attention to detail. So first of all, you can't. So the USB port is very securely connected. So it's molded into the housing, and this is just strong as shit. It also has this very nice little frame, I guess you could call it, around the USB, just making it that much nicer, right? And this is the Apple supply. So I've unfortunately ripped the fusible. It's actually not a fusible resistor, it's an actual, let's check it out, it's an actual fuse. So yeah, this is a very neat little 2 amp ceramic fuse, which also was surrounded by heat shrink to contain any explosions. So let me actually check if this is blown, because as I said, this charger had absolutely no output on it. Holy shit, so the fuse is blown. Holy crap. Let me see this again. Yeah, the fuse is open circuit. How neat. Alright, so this Flextronics, was it? Yeah, this Flextronics iPad adapter failed because the fuse blew on it. Obviously this is not user replaceable in the slightest, but nonetheless. What's left now is to actually try and power this up and see if it works. So give me a moment for that. I'll be right back. Let's first of all check if there's any type of short on the input, because that would be very unfortunate. Can you guys see this? Alright, so alright, so I feel mildly confident in plugging this in. I will somewhat stand back though, no reason. Alright, so it's not doing anything. Just give it a second in case it wants to blow up. Alright, let's unplug it. And keep in mind, the filter capacitors should still be live. I'm pretty sure there's some bleed resistors over here. But yeah, I'm not gonna poke my fingers across. So yeah, let's first try powering up a simple load. Yay, it does work. So next up, let's try and load it down and see how it behaves under load. Right, so I've got these pretty imprecise power monitors hooked up, but they should give us some ballpark values. We have 5.07 volts at 2.6 amps. The sense resistor in these is pretty big, so already here we're getting like 4.5 volts instead of the 5 we're seeing here. Let me very quickly measure how much we actually have on the board. Can you guys see this? You can. Alright, so 5.16 volts at the output. So that is not too bad. And again, we're drawing 2.6 amps, so this is pretty much in spec, I would say. Alright, so let's let this sit here for a while, and I'll be right back. So it's already been cooking for a little while, so I think I'm reasonably satisfied that it is a fully functional unit. Let's see how hot it got. Let's first see if there's any voltage on the main caps. There is some, but it should be fine. Alright, I'll try not to touch them anyway. So yeah, the construction on this is pornographic. So there's insane separation. So you see they cut this huge L-shaped groove. These appear to be some capacitors. They've applied some silicon goop over the bridge rectifier for some reason. I think thermal reasons. Although, yeah, I don't know. And over here, apart from that, it's not been covered in this goop. Alright, yeah, so we just have this optocoupler. This is basically the clearance. And apart from that, we have this huge L-shaped groove. So we do have some secondary side feedback. We have two white glass capacitors. And the transformer windings are going to the other side of the board. So very nice. And this seems to be quadruple insulated shit. So there's first of all two wires that are intertwined, and then there's another sleeve. I'm not sure if, yeah, let's see if we can see that. I think this outer sleeve, the milky one, also is present on the inside of the transformer. Seem to have the switching transistor here. Control chip, bridge rectifier, not a lot, right? So it's just done to a very, very high standard. Yeah, so this is how an original Flextronics USB adapter should look. Alright, so there's another chip here, probably has something to do with Apple devices, because as I've said, this does act quite strangely. So it will refuse to power something, so simple stupid load, so like a normal Nokia phone, it might have trouble charging. I don't know what exactly those do that this doesn't like, but I think this chip has a lot to do with it. Seems to be a Fairchild something or other. You can read the number. Alright, so yeah, that's pretty much all there is to it. So let's get on to the next ones. Alright, so next up is the fake Flextronics, so the one that's trying to emulate the one that we just tore down. And yeah, this is obviously fake, so the earth stud was completely a dud, basically. So this took basically a third of the time, at the very most. Either way, this is a pretty good clone. So I'm not that... well, it depends, right? Like on how the power is. I don't have an oscilloscope to actually measure the performance of the ripple and the isolation of this design. But they also have a little bracket here So the cloning effort has been quite perseverant, right? So they also have this little part here. I don't know if they copied it just. So this is the clone one, and I'm bringing in the original one. So I don't know if they really wanted to copy absolutely everything, but they also have the little holder for the USB port, which is a very nice nice call, right? So basically the USB would go in like this. So it's strapped onto the board here, and because it's vertical, right, you're just shoving shit into it all the time. It really does help to have some support on the back, which this one does have. It's not as it's not all rounded like the Apple one is, but the walls are a bit thicker. This plastic I would assume has no markings, but it doesn't seem to be polycarbonate, so it behaves quite differently from this one. It also has less of a shine to it. So enough about the case. Obviously there's going to be no internal earthing. There's no fuse on this, not even a fusible resistor, so it's something to keep in mind. Input cap is 400 volts, very nice, 10 micro. There's this bowl logo on it, I've never seen that before. But it actually does look fairly okay quality. I mean, I don't know. Well, for a Chinese one, obviously. Chongx for the small cap. Gotta love them. And I think this diode has actually failed. And someone has been overloading this, as you can see. It's quite cooked around the diode, so I wouldn't be surprised if that's what failed. And I wonder why it got so hot. So someone really put a huge load onto this. Imagine the ripple that gets out of this. 1000 micro, 10 volts, same brand. So again, very nice. They're using the same brand for the main capacitors. I mean, that's a good sign, right? I don't know. The ports, they've made a pretty hard effort to actually emulate us, right? They have the writing inside of it. It seems high quality. I mean, see how the fit feels. Yeah, it's a bit looser than the Apple one, but still very nice, right? Very snug. Well, I don't know. Nothing wrong about that. Let's actually measure the diode first, because I think that's broken in 0 volts. All right. 0 volts. All right. So this diode here has failed short circuit, which does seem to go hand in hand with how much it cooked over here. They've actually provided spots for 2 diodes in parallel. Holy goddamn shit, I wonder why. I've never actually seen designs use that many diodes in parallel for just a small charger, but I don't know. I think it's because, I don't know, I guess they're shittier, so they want the, I don't know. Let's try and actually replace this and see if it works afterwards. So now I've replaced the diode. Just look at the charring on the board. Damn, that must have gotten hot, like 100 degrees, or how hot did that get to char this? And keep in mind, it was standing up, right? So it only affected the board through the wires, the leads. Alright, so always before testing shit like this, test if there's any short, cross it. And in this case it seems fine. Alright, so it does work, but it creates this very intense high-pitched noise. I'm pretty sure this is intense enough so you can hear it across the camera. There's no visible flicker on the output. Holy shit. So very nice construction on the case. So whoever was in charge of cloning the case did a very good job. Very good job indeed. And they also probably avoided some lawsuits by just writing company ink here instead of Apple ink. But whoever did or chose the power supply did a shitty job. This is a piece of shit. Alright, so whatever that is in charge of making all the noise. And I think the switching transistor is inside of that because there's nothing else really on here. Let's see the separation. And it's very bad. So last up is the Foxlink 5-watt iPod adapter. So this is the oldest of the bunch, and it also doesn't work. So yeah, let's take this one apart. I also think this one is original Apple, so this should be difficult to tear down. But yeah, let's see. So basically, a good way of tearing these down is to create yourself tear yourself a lip around. So right off the bat, I can tell you guys that this is 500% an Apple design. So check out this part, just how high quality it is and how many parts. So this is how the stud is connected. So it's not one part. No. It goes polycarbonate, both parts, right? PC. And they've heat staked it onto here. And this is why these chargers are so expensive. I mean, obviously the cost is not equal to the price, but nonetheless, it's good to see that you actually do get quite a lot of quality. And it does have the Foxlink logo and the Volex logos in here. Alright, so Foxlink and Volex. And yeah, just this part alone, you're not gonna find this kind of high quality craftsmanship in a clone. It's not worth it in any case. We have the fuse again. So this is the 2008 Plus iPod adapter. Copyright 2008 on the bottom. I would venture to say this is also definitely an original Apple part. The USB port was again sustained by, supported by this this structure that also had some ribs in here for extra added rigidity. So this thing really is built like a tank. So the present day one is also incredibly strong. This one is stupidly strong. They also keep putting these little washers around the USB every time. Layout, so it's pretty similar to the 12-watt one, just weaker. So the problem on this one is the vent caps have almost vented, so I am 99% sure that I didn't do this. Now, so the input caps are TK, and they're put in such a way so you cannot see the ratings. There's this weird standoff board here. I don't know what exactly this does, but if anyone knows, feel free to chime in. There's a transistor here actually, hidden away. There's also 3 wires going to this, so I have no idea what that is. Perhaps some thermal protection, I don't know. Full bridge. The switch mode chip, so a very small one this time. Perhaps there's another one. Yeah, I can't really. Yeah, let's try and check it out. Ah, fuck, I fucked it up. I'll probably be able to put this back though. So there's just 2 transistors here, which fairly large separation. We do not seem to have any low side regulation. So there's no optocoupler in this design. There's just the wires from the transformer going through, which does completely and fully explain why we had the huge voltage fluctuations. Right, given that this microcontroller here does not know what exactly is going on the low side, right? So we have this, again, 5-pin chip. That's most likely the switch mode chip. A bridge rectifier. Very inelegantly placed capacitor over here. So this is very bad if you've, excuse again the uncut hand nails. If you watch the last, I'll include it in the description actually, Dave Jones did a video on a power supply that basically caught fire because of one of these. So it doesn't seem to be across anything in this particular case, but I don't know, it just looks like shit around here, right? So, and this is mains. So I don't know, I would have appreciated. So the newer design is definitely a lot cleaner. So yeah, the newer design, you can see the board is basically the same, but they went into Apple style black boards and just way cleaner. So yeah. Alright, so looking at these capacitors, it's pretty bad. They're Yikon brand, and the other ones are also non-brand. I'm not sure if this actually is an Apple supply. It's very close. I mean, if it's a clone, then why the hell would it be using Foxlink, original Foxlink transformers? I mean, I guess Apple really was using shitty capacitors back in the day. But yeah, this was supposed to be 820 microfarads at 6.3 volts, 103 degrees. So let's see what it measures. Nothing. So yeah, this is completely dead. The other one is Vent, so not even the same brand, right? I mean, geez, 1500 microfarads, so a lot of capacitance on the output, which, yeah, right, I guess not bad, but I don't know. And yeah, these don't register as absolutely anything. Okay, so I've attached a 1000 microfarad capacitor to the output and reattached this daughter board with the two transistors. And bodged in these two wires. And yeah, let's see if she does anything, and then we'll connect the load to it. Okay, fair enough. So let's first connect the passive load, because I don't want to bust my power monitors if something is terribly wrong, but I do expect it to work at the moment, so yeah. Alright, and it does. And you can see some oscillations, right? So even with the capacitor at power down, it does have some instabilities, and these instabilities it used to have with the shitty capacitors. I actually now regret not powering this with the unstable one, so we could have actually seen the instabilities, but yeah, it is what it is. Not good. Alright. So even with the capacitor, it still doesn't keep a high enough voltage on the output. Right, so this is what it used to do before as well. So it is just absolutely all over the place. So yeah, something is definitely wrong with this one. Completely unrecoverable. And also not that beautiful of a design, so I'm not too disappointed about that. Let's try the load again. So this is like 400 milliamps, for fuck's sakes, man. I mean, alright, so it can't even sustain a 500 milliamp load. So something is definitely busted with this. Not sure exactly what, so it's either the main switching transistor here or something else, because it's pretty fucked up. I'm curious to see if it works without the daughter board though, so let's try that up next. Hey, it does actually work without it. Wouldn't you know it? What the fuck is this then? Yeah, if someone can tell us, that would be just great. I have a lot of writing and test points on it. Damn, this is a weird board. So yeah. Quite awkward. It does still work without it though, so yeah. Let's see if it's actually better without this, because up to now it seems exactly the same. And given that it's on the high side, I don't think it has anything to do with the iPods. Right? Because back in the day some iPods would have this this boot problem where they would say connect to an Apple charger or something like that. And I don't think it didn't work if you connected it to a computer. So you had to actually connect it to an Apple charger. I'm not sure if you could have connected it to a normal charger back in the day when I had this problem with an iPod. I just connected it to an Apple charger and then it immediately starts working again. So I think it's after you do a restore, it by default asks you to connect it to one of these. I have no idea why, or something along those lines. But yeah, so let's check and see how it behaves now. It's actually a bit better. Let's plug in the lights. Ooh, it's going down. Now it really doesn't have a lot of power. Really does not. Let's try the 500 milliamp load. And no, it still completely kills it. But yeah, if anyone knows what that does, definitely let me know. I am very curious to know. So yeah, that is a wrap up. So yeah, any questions, leave them down in the comments, and have a good one.